Ever pondered on the step-by-step procedure that transforms a mere concept into a refined software product? The answer lies in a disciplined approach known as the spiral model. The spiral model is a unique software development process that intricately combines the elements of design and prototyping in stages. The model follows a systematic approach to develop new software, taking one feature at a time, reviewing it, and then progressing to the next. The brilliance of the spiral model doesn't end here. It also addresses the shortcomings of traditional waterfall model. While the waterfall model follows a linear approach, making it challenging to go back to previous stages for corrections or changes, the spiral model provides flexibility, allowing developers to revisit and revise, thereby ensuring a more refined product. The spiral model is particularly beneficial in scenarios where there's a dependency between different software modules or features. It allows for the systematic development and testing of dependent features, ensuring their seamless integration into the final software product. First depicted by Barry Boehm in his 1986 paper, the spiral model's practical and adaptive approach has led to its widespread adoption in software development processes. The initial stage in the development of Module A is the planning phase. Here, objectives are pinpointed and the feasibility of the module is examined. This is the juncture where the customer steps in, providing a list of requirements that they envision for Module A. This key information is then gathered and consolidated by the business analyst. The analyst is responsible not only for the collection of these requirements, but also for the crucial task of conducting a feasibility study. They discern whether the project can be executed within the constraints of time, cost, and resources, and with the available technology. After this meticulous evaluation is conducted, the architect assumes the helm. Their role is to design the module, laying out the plan that best fulfills the customer's requirements while also maintaining practicality and feasibility. This planning phase is the bedrock upon which Module A is built. Absence of thorough planning at this stage could lead to increased chances of project derailment. Moving on to the second phase, we delve into risk analysis within the context of Module A. Once the objectives for Module A are clearly defined, our team begins to identify and analyze any potential risks that may surface. This detailed analysis is a vital stage in the process as it equips the team with necessary preparation for the possible challenges that may arise during the coding of this specific module. The developer establishes the best possible solutions to these potential risks and formulates a robust plan to address them head-on. Once this is done, the developer begins to code the module. After completing the coding, they hands over the module to the test engineer. The test engineer meticulously tests the module, and if any defects are found, they are promptly communicated back to the developer. The developer then fixes the defects, ensuring that Module A is free from any bug and operates in the most efficient manner possible. The third stage is specifically the engineering phase for Module B. At this point, the true fabrication of the software transpires. The team commences the construction of the software based on the predetermined planning and risk assessment. An aspect of this process involves the developer taking a copy of the code from Module A. With this code in hand, they proceed to write the code for Module B, constructing it in with the needs and objectives established during the planning phase. This doesn't just happen in isolation. The developer also writes the integration code, which acts as a bridge for Module A and B. This phase encapsulates coding, testing, and deploying the software, all within a regulated environment. It's crucial to ensure that the software developed, particularly Module B, accomplishes the objectives identified in the planning phase. The fourth and concluding stage pertains to evaluation, specifically focusing on Module B. Once Module B has been and integrated with the software, it's essential to gauge its functionality. The test engineer comes into play here, scrutinizing the newly developed Module B meticulously. But that's not where the test engineer's job ends. The next step involves assessing the interworking of Module B with Module A, ensuring seamless integration. The test engineer also revisits the pre-existing Module A to confirm continued efficiency. Any bugs or anomalies discovered in the process are promptly ironed out. Once both Modules A and B have been thoroughly tested and approved, and the software quality is found to be optimal, it's finally time for them to see the light of day. The modules are then launched and delivered to the awaiting customer. This completes the evaluation phase. The striking feature of the spiral model is its iterative nature. Unlike a one-time process, it operates in a cyclical manner, repeating phases in every iteration. After the evaluation phase culminates, the same process recommences from the planning phase. This repetitive pattern facilitates uninterrupted enhancement and modifications. Just as the model's name suggests, the process, much like a spiral, continues to revolve in a cycle and evolve with every rotation, making the model extremely iterative. The spiral model, in its essence, serves as an incremental system for software project management. With every spiraling cycle, new modules or features are introduced and integrated into the project, reflecting the incremental nature of this model. This incremental approach ensures the addition of fresh at each iteration, thereby progressively growing the software in functionality and complexity. Each loop of the spiral signifies a new phase of development, a phase where enhancements are made and innovative features are added. Therefore, the spiral model is not just a roadmap for managing risks and fostering continuous improvement, but also an embodiment of incremental development, which transforms software creation from a chaotic task into a well-orchestrated methodical progression. Hence, the next time you find yourself captivated by a piece of software, take a moment to appreciate the complex procedure behind its formation. It is crucial to understand and appreciate this intricate process. The spiral model, the often overlooked champion of software development, plays a vital role in this endeavor,